Hello guys, hope you are doing extremely well. This is your very own mass coder this side, and today we are going to solve the problem threesome. It is quite an important problem and a renowned problem as well. Okay, so what does the problem say? It is on the lead code and the problem number is 15, right? The problem number is 15 on lead code, right? Okay, so the problem says that you have been given an array. As you can see here, the array given to you is -1, 0, 1, 2, -1, -4, right? Now, as the problem name also suggests, threesome, that is you have to pick out three elements and sum them up, right? Three elements sum. Now, the problems demand you that the three elements sum should be equals to 0. That is, you have to give me triplets whose sum is 0, whose sum is 0. Pretty easy problem, right? But there are some extra constraints attached to the problem. The problem says that the solution set must not contain duplicate triplets. What does that mean? What does that mean? Let me take a look into it. So -1, 0, 1, 2, -1, -4. This is my array, right? This is my array, right? So what are the possible triplets I can form? Let us say this one and this one are actually different. This one and this one are actually different, but the values are same, right? So I can mark it as 1 and I can mark it as 2. So if I take a closer look, I will be able to find that the triplets that exist are -1, 1, 0. This is one of my triplet, and this triplet can be formed either by this one or by -1, 1, 0, or by this one. I am saying that this triplet can be formed using either one, using either -1, right? Using either -1. Another triplet that is possible is -1, -1, 2. The sum you can see it is 0, right? So I was able to find these triplets only in the problem. It might be possible that in the solution we can find another one. So if we look at the output given to us in the example, you can see there are only two triplets, 1 and 2. But we have found three triplets. This is my first triplet, this is my second triplet, this is my third triplet, right? Okay, so I will have to leave out one of these two, Why? Because actually these two -1s are not different, these are actually the same. So they will be counted as duplicate, and I will actually select only one of them. So -1, 1, 0, -1, 1, 0. All right. So I hope that the problem is understood to you. You have to give me the triplets whose sum is equal to 0, and the triplets must not be duplicated. Also, you can see that the order of the output does not matter. That is, I can actually give this as my answer, or I can also give my answer as -1, 0, 1 with -1, -1, 2, right? This is also my potential answer. Plus guys, order of triplets also not matter. So -1, 0, 1 can be presented as -1, 1, 0 is as your answer, as your output, or it can be presented as 0, -1, 1, or any other permutation of the elements, right? Or any other permutation of the elements. So I hope you are clear with the input and output scheme of the problem, right? Let us delve into the solution. Okay, so the question demands me triplets. The question demands me triplets. So it is very easy. What will I use? I will use nested loops. I will use the concept of nested loops, right? As you know, we always look at the brute force solution every time. So what will my nested loop look like? So I will go from 0 up till n-1. That is the last element present in the array, right? I will go from j. Now j will actually start from I plus 1, because my I should not be equal to j. It is given here that all the elements should be distinct. It is given here that all the elements should be distinct. I should not be equal to j, and I should not be equal to k, as well as j should not be equal to k, right? All the elements should be distinct. So to make sure that they are distinct, I will go from j equals to I plus 1 to n-1, and similarly I will go from k equals to j plus 1 n-1. And you can dry run this easily. You will see that all the triplets that arise are actually unique indices, right? And all the cases will be explored. All the cases will be explored. You don't have to worry about that. For making it sure, like getting a feel of it, you should dry run it on your own, marking all the indexes and see what are the outputs that you are observing for the indexes, right? Okay, now what was our condition? We wanted to get the sum as 0. So my elements are actually a of I, a of j, a of k. Given that my array is named as a, right? So what will I say? I will give a condition that if a of I plus a of j plus a of k equals to 0, that is we are getting the sum as 0. What will I say? I will say answer dot push back the vector. The vector is a of I with a of j with a of k, right? But there is a problem in this code. There is one problem in this code. What is the problem? We are not handling the constraint which was for duplicates, that can be easily dealt with. I can use a data structure known as set, which will eliminate the duplicates. I will use set of vector of int, right? And instead of inserting into the answer, I will first insert this into set, that is set dot insert this particular bracket, and after all the three loops are finished, I will push all the elements of the set, that is push all the elements of the set into your answer vector, and you got your answer, right? And you got your answer. The question, the approach should be very easy, very easily understandable, right? Very easily understandable. What is the time complexity here? So you can see this is actually running n times, this is actually running n times, this is actually running n times. So it is O of n cube, O of n cube. Pretty inefficient, pretty inefficient. Also you are inserting in set, so it takes extra time for that. I guess it is log n, so let us not delve into it. But O of n cube is actually short, right? And because of the set, the space complexity is also getting increased. Is there something I can do to optimize the problem? Is there something I can do to optimize? I want to optimize the problem. So my array given to me is -1 0 -1 2 1 -4, right? This is my array. This is my array. See, the thing you should keep in mind, order does not matter. That is the key that I am getting. Order does not matter. I am saying, will it be easier for me if I sort it down? It might be wrong, but let us sort it down. I'd say first step is to sort. After sorting, your array becomes something like this: -1, -1, 0, 1, 2, and -4 will come here, right? Because -4 is the smallest value. -4 is the smallest value. I say, if I keep my pointer I here, my I comes out to be here, right? See, I'm saying that it might be possible that it is possible to form a triplet with I as a value. It might be possible to form the triplet with I as a value. Yes, you say it is correct, right? Okay. So I have to find J and K in remaining I plus 1 to n minus 1. I have to find J and K in remaining I plus 1 to n minus 1. That is where your two pointer approach will come. How will I use two pointer to facilitate and decrease my time complexity, right? And decrease my time complexity. I'll say if I keep my J here, if I keep my K here, right, I will calculate AI plus AJ plus AK. What is that? It is -4 -1 plus 2. That is equals to -5 plus 2 gives me -3. -3 is actually less than 0. -3 is actually less than 0. And because I'm saying, because the array is sorted, because we just sorted it, because the array is sorted, we are sure that A of j is actually less than equals to A of k. We are actually sure of that A of j is actually less than equals to A of k. Are we sure upon that? A of j will be actually less than A of k because it is sorted, right? So we are on -3, right? To reach 0, we have to increase this sum. We have to increase this sum. So as to increase this sum, I can either move j forward or I can move k forward, because I am putting my I as permanent. I am putting my I as permanent. This is a nail and I just smash the nail into the -4 and I will not move. I can either move j forward to explore more. I can either move k forward to explore more, right? Now, because my sum is actually smaller and I want to increase it, will it not be great for me if I increment my j? Will it not be great for me if I increment my j? Yes, it will be incremented, right? It will be great for me if am able to increment my j. So I will say that if sum is less than 0, because 0 is my target value, what will I say? I will say j plus plus. See, don't delve into the duplicates right now. I will tell you how to handle the duplicates also. That is also very easy. Else, sum is greater than 0. See, if the situation in hand would have been something like that, we have the sum of 5, which is actually greater than 0. So I will have to decrease it down. Decrease it down. A of j is contributing to my sum. A of k is contributing my sum, right? But A of k is actually contributing more because A of k has a greater value. So as to decrease this value, I will have to say k minus minus. If it is giving more, I will reduce it so as to reduce my sum. Okay. So I will say if sum is greater than 0, I will say else if here sum is greater than 0, I will say k minus minus, right? What is the condition left, guys? What is the condition left? The condition left is sum is equals to 0. Sum is equals to 0. Do I have to deal with it? Right? Do I have to deal with it? No, I don't have to deal with it. Why? Because if sum is greater than 0, then that is a valid triplet. Valid triplet. Just push it into the answer and move forward, right? And move forward, right? Now, how will we do the things, right? So I am saying my array given to me is -1, 0, -1, 2, 2, 1, 4. I suppose this is my array. After sorting it down, it became, this is -4 here, -4, -1, -1, 0, 1, 2, 4. So stay focused because now we will be dealing with the duplicates as well, right? I say I will make a vector of vector int to store my answer, right? That is permanent, right? I want to store my answer in a vector or vector int type named as answer, right? What will I say? I am saying that I am moving my I, right? So my I is actually going from 0 up till the last element, right? Okay. Now I said that I have to find j in the remaining element. I have to find j in the remaining array. I have to find j and k in the remaining array. So what is my j here? It is starting from I plus 1. What is my k here? It is starting from n minus 1. It is starting from n minus 1. I will put that. So I will say j equals to I plus 1 and k equals to n minus 1. No problem up till now. Okay. Now, now I will have to explore all the cases. To explore all the cases, I will use loop. I will take the help of loop. Now, up until when j will increase, my j is actually here, my k is actually here, right? My sum is I plus j plus k. Now, suppose I move my j here, and in the next step I move my k here, I move my j here, I move my k here. I move my j here, I move my k here. Do I need to iterate right now also? Do I need to iterate now when k is actually smaller than j? When k is actually smaller than j. See, the operations will be now repeated. Operations now will be repeated. Because if k is less than j, then actually a of k will be less than j of j, right? So my operations will end up till j is less than k. Because if they are equal, then the triplet is not forming. We are actually using an element twice, right? Okay. While j is less than k. What is my sum? My sum will be a of I plus a of j plus a of k, right? Now, first condition, I am using the first condition as sum is equals to 0. That is, I have found my one of the valid triplets. One of the valid triplets. In that case, I will say answer dot push back. What do I have to push back? I have to push back the vector ai, a of j, a of k, right? And now I have to increment my j and decrement my k I'm not writing k plus plus or k minus 1 etc etc. I'm writing a proper function to explain you how we will deal with the duplicates here, right? This function I'm making for duplicates. I will do it in the code itself, but nothing to be scared of, right? The second condition is else if sum is less than 0. If sum is less than 0, that means a of j should be increased so as to increase the sum. A of j should be increased, that is j plus plus, right? The third condition, the remaining condition is sum is greater than 0. In that case, k minus minus. In that case, k minus minus. The loop will end. This inner loop will end, right? This inner loop will end. And now I have to increment my I, which will be incremented automatically in the for loop, right? Which will be incremented automatically in the for loop. So I don't feel any type of problem. I don't feel any type of problem. I'm perfectly sure that we can actually move towards the coding area. We can actually move towards the dry run area. Okay. So It was minus 4, minus 1, minus 1, 0, 1, 2, 4. Right? This is my array. Index is a 0, 1, 2, 3, 4, 5, 6. Right? Okay. I say my I is 0 right now. So my I is actually here. My j will be here and my k will be here. My sums come out to be minus 4, minus 1. This is not 4, it is 2 here. Okay. Minus 1, minus 4 and 2. Right. It will be equals to minus 3. Because the sum is less than 0, my j will actually come here. The sum becomes minus 4 minus 1 plus 2. That sum remains same. So I say minus 3 remains same. I will increment my j again. Minus 4 plus 0 plus 2, which will give me minus 2. Again less. So j will come here. Okay. So minus 4 plus 1 plus 2, which is equals to 1. J will come here. Now j and k are equal, so I will have to end my inner loop, and I'm not able to find any triplet for this side. Okay. Now my I comes here, my j is actually here, my k is actually here, right? The pair becomes minus 1 plus minus 1 plus 2, which will give me 0. I found a 0. Guys, I found a 0. Now a 0 has been found. Now I will have to push it into my answer. So my answer becomes minus 1, minus 1, 2. Right? And because elements are this with this with this, right? I will not use these elements again, these both elements again with this j, right? So I will move my j forward, that is my j will actually come here, my k will come here, and I will now start again traversing. That is why I said increment j, decrement k, right? Now the new pair becomes minus 1, 0, 1. I will push it into the answer. I will push that into the answer because that is also giving me 0. So my second answer, second vector becomes minus 1, 0, 1. Right? Now, at the time of incrementing I now, at the time of incrementing I, my I is actually here and I will increment it up till here. Right? My I will come here. But you can see minus 1 here, minus 1 here. My I is getting the same value. I is getting the same value. It might lead to me the duplicate case, So I will increment I up till a of I is not equals to a of I minus 1, so as to get cautious of the fact that this can lead to duplicates. And similarly, while incrementing j and decrementing k, these things have to be noticed, right? Increment I up till ai is not equals to ai minus 1, and that is clear for sure. That is very easy to understand, right? Okay, let us deal with the time complexity and space complexity and let us move forward. So the time complexity, it is clearly visible, it is running n number of times, right? And this also, if you see, my j and k are actually from here till here and are actually doing n operations, not n operations, it is n minus I operations. But in the case of nested loop, it will become O of n square, and the space complexity is O of n. We are just using a space to store the answer, right? Okay, so it's time to move on to the code section and get you done with the code. Okay guys, so here we are, and before starting to code it down, I would like to request you to subscribe to my channel if you're new here, and do not forget to hit the like button as much as possible because it really motivates me. Also, I would like you to that if you have any problem in any of the LeetCode question, please comment down the problem and I will try to bring the next video on that particular problem as well. Okay, so thank you for watching, and this is the coding starting. So vector int answer. Pretty simple, right? Now I will make my pointer as int I equals to 0. I'll say first I will take the n, that is size, right? So int n equals to nums dot size, right? Now while my I is actually less than n, what will I do? I will say my int j becomes I plus 1, that is a particularly next element, and k becomes n minus 1. My inner loop will work while j is actually less than k, and my sum will become, what is my nums? It is nums. So nums I plus nums j plus nums k, right? So now if we get the value of sum as 0, that is we have found the triplet successfully. In that case, answer dot push back. What do I push back? I push back nums I with nums j with nums k, right? Now I will have to increment my j and k, right? So I will say while j is less than k and nums of j is equals to nums of k, so as to avoid the case of duplicates. Not k, it will be j minus 1, right? I'll say j plus plus. And similarly for the k, while j is less than k, and because we are decrementing it, so we will clear it up with the k plus 1. So nums of k plus 1, k minus minus, right? Now else if sum is actually less than 0, in that case use this loop to increment your j. Use this exact loop to increment your j, right? And similarly here you can also do simple j plus plus, but I prefer this to avoid the concurrent operations. And similarly you can do same for this to decrement your k, okay. Now after this while loop has been finished, I move my I forward. Now I will have to increment I up till the same. Now while I is less than n and nums of I is actually equals to nums of I minus 1, what will I do? I'll say I plus plus. And at last I will return my answer. Let us try to compile and run it now. Oh, so it is even time limit exceeded, because I forgot to mention that it will have to work at least once, right? J plus plus, and here I will say after pushing back j plus plus and k minus minus, and below also I will say I plus plus. Let us try to compile and run it now. So an error again. Can anyone tell me what mistake did I do? I did the basic mistake of not sorting the nums. So I will have to do sort nums dot begin with nums dot end. This is not the first time I'm committing this mistake. I actually forget in writing the code that I have to sort the array also. I have to pre-process the array. What is the mistake? Oh, comma is a mistake. Let us try to fix it. 4 mistakes in a code. Sorry for that. So accepted, and let us try to do it for submit as well. Hope it will get run and produce the correct. Okay, submitted. Thank you for watching and have a nice day. If you have any doubts in any of the LeetCode question, comment down the problem number and I will surely bring out a video ASAP. Okay. Thank you for watching. Have a nice day. Bye.